Okay, I'm going to pick back up with you where we left off on our derivative rules. So what I have on the screen is just a recap from where we left off. And we're looking at a couple examples where we have a multitude of functions. So a function that's defined as maybe a sum or a difference of two other functions, or a product of two functions. So in the first example, f of x equals x squared minus 4x. This is the first example that we ever looked at with taking derivative. Go back to your chapter 3 intro packet. And what we see is that we can take the derivative of the first term x squared and get 2x. Take the derivative of the second term, negative 4x, which is negative 4. And what happens is the derivative of your sum or difference, in this case, of two functions becomes the difference of their two derivatives. You literally take the derivatives separately. So this is how we can get more complex polynomials than something just like x cubed. We can have x cubed plus 4x squared minus 5x plus 1, and we just do the derivative of each piece separately. So that is whenever you're doing a sum or a difference, that is okay. To probably do basically what you would think of doing. Okay, and we'll formalize that in just a second. Take a look at the second example, and we've got g of x equals x squared. On the left-hand side, I have done what we would normally do, which is just do the power rule. So x squared becomes 2x. So we know the answer has to be 2x. On the right-hand side, I've redefined g of x as x times x. So make sure you agree with me. X squared is really just equal to x times x. And then I've taken the derivative of each term. So derivative of x is 1, derivative of x is 1. Taken the derivative of each term and tried to multiply them together. Just the same as I did here, where I did the derivative of each term and then just kept the sign the same, which is subtraction. And when I get 1 times 1, that's obviously 1. Notice that my answer is not matching up with what my answer should be. So I've got an answer of here. Whoops. Sorry about that. Answer of 2x and an answer of 1. And those are not matching, which means that I'm going to need to do something different when I have two functions being multiplied together to get their correct derivative, because I want to somehow come up with 2x. Big picture, it's not always going to be something that I can just rewrite x squared as, or x times x as x squared. This could be x times sine of x. This could be x times natural log of x. This could be sine x times natural log of x. It could be two totally different functions that you can't actually multiply together and simplify. So in a second here, I'm going to define a product rule, and then we're going to test it out. We'll come back to this example. I just wanted to make sure you had like a vision of where we were going with this. So I would get to your notes where we're writing down our rules, and we're going to write down some more rules. So let's make rule number 4. I believe we left off with 3 being the constant multiple rule. So rule 4 is going to be the sum or difference rule. And I'm going to write it 2 ways. This is partly just so that we can get used to our notation. And some people will like one way better, some people will like the other way better. Whoops. Sorry, technical difficulties. Okay, so derivative of your function f of x plus or minus some other function g of x is equal to f prime of x plus or minus g prime of x is one way of writing it. A second way of writing the same thing is we can call our functions u and v, and this just becomes maybe a little bit easier because we don't have the of x that we have to write every time. So if I just make my functions u and v, then I can just say I have to take the derivative of u with respect to x. This is the same as when we had y and we ended up with dy dx, plus or minus the derivative of v with respect to x. So that is for whenever we have sum or difference. Rule number 5 is going to be our product rule. So let's go ahead and do rule number 5. Okay, so it's going to be a little bit more to write. Okay, derivative of some function f times some function g becomes the first function times the derivative of the second. So notice that's g prime of x that I just wrote, plus the second function times the derivative of the first function. So if we just take a look at this for a second, you'll notice a few things. Here's our derivatives, g prime and f prime, but you're multiplying them by the actual functions themselves, and then you're just actually adding two parts together. So notice we have the functions themselves right there. Okay, there's of course a second way of writing it, and again, this is just a notation thing, so one might make more sense to you. I'm going to go ahead and do it just for the practice. Derivative of some function u times some function v is going to be u times v dx plus v times du dx. Okay, now I promised we'd go back to our examples, so let's go back to our example, and we're going to do a very basic one. Let's start with the one that was kind of our one we got stuck on and reason we needed a rule, and we're going to verify that this does work. So we said a minute ago, if f of x was x squared, we could rewrite that as f of x equals x times x, and we know that the derivative should be (2x). So in a second here, I'm going to make sure I do get this answer of 2x. And the way I'm going to do it is I'm going to go and use my rule. My rule tells me that I'm going to have to do first f of x and then g prime of x. And this one's going to be a little weird because my f and g are actually the same function. They're both x. Okay, so I'm going to talk you through it as I do it. But I'm going to do the first one times derivative of the second, which is going to be clean that up a second. So I'm taking the first function itself times derivative of the second. So derivative is going to be derivative of this one, which is 1, plus, always a plus sign in the middle. That's not changing, it's coming from right here. Plus derivative of the second function itself, so now I'm just doing x for that term, times derivative of that function, which is going to, derivative of the first function, f prime of x, which is 1. And now I'm just going to do the math. The math ends up coming out to be, obviously, x plus x, and we're getting 2x there, which does indeed match with our original. Okay, hopefully that's a quick example that convinces you that the product rule does work. I obviously don't want to just tell you something and you not understand why it works. I would love to derive this one. It's going to take a lot of time, so we're going to skip the derivation for right now, but if you're curious, we can always go back and do it. Okay, right now I've shown you an example where we get the same answer by using the power rule, on the left versus using the product rule on the right. And we're actually going to do that one more time, this time with a more interesting example where we don't have x times x. We've got two different functions that we're doing. But let's stick with a polynomial for now and do a second example. So function this time, we're going to go with f of x equals quantity x minus 5 times quantity x squared plus 2. And we're going to call the first one my u, and the second one my v function, or f and g is fine as well. And let's go ahead and apply our product rule. So I'm going to write it out a little bit more detailed this time so you can follow what I'm doing, hopefully. So we've got f prime is equal to my u function. So I'm going to go ahead and write that one as is. X minus 5 times the derivative of x squared plus 2. I'm not going to take the derivative yet. I'm just noting I need to take the derivative. Plus second function, which is x squared plus 2, as is, times the derivative of the first function, which is x minus 5. So now what I need to do is I need to actually go and take the derivative. So I'm going to take this and this and actually evaluate what the derivatives are. Derivative of x squared plus 2 is 2x, plus derivative of a constant is 0. So I'm not going to have anything there. You can write 2x plus 0, or just 2x. And derivative of x minus 5 is going to be 1 for derivative of x. Derivative of negative 5 is 0. So I'm using my sum or difference rule there, but I'm ending up with a 0. Let's rewrite what we have for our other terms, because those aren't changing. So we have x minus 5 times quantity 2x plus x squared plus 2 times 1. And now let's just do some algebra here. So I'm going to distribute 2x squared minus 10x plus x squared plus 2. And it seems to me we can combine stuff here. So 2x squared plus x squared is obviously 3x squared minus 10x plus 2 is what I'm getting for my final answer for my derivative of our original function. Now, that's great, but I'd really like to test this since this is one that I can do a couple different ways. Let's go ahead and multiply it out. So we're going to go back to our original function up here, and we're going to multiply out our function, our two binomials, to get a trinomial, and then we're going to take the derivative using our sum or difference rule, which is probably obviously easier. I guess it's a matter of opinion, because you will have the extra step of multiplying. The derivative will end up being easier. We should get the same answer, and that's what I'm going for, is a little more verification that this rule actually does work. So if I go ahead and rewrite that function, I'm going to have x cubed, and then I'm going to have, so x times x squared, x times 2, it'd be 2x minus 5x squared minus 10. And I know that's not exactly in perfect order, but for the sake of time, I'm going to go ahead and not rewrite it. Let's just go ahead and take our derivative, and we're going to get f prime of x equals 3x squared for my first term, plus 2 for my second term, minus 5 times 2, bring the power out front, x, drop it by a power of 1, and then minus 10 would be 0, so I don't need that. And I'm ending up with 3x squared plus 2 minus 10x. We're comparing that to that, and we're noticing that other than order, we have the exact same derivative. So hopefully you're convinced now at this point that the product rule does work, and you are going to do some practice with applying it. There are a couple examples in your My Math Lab assignment where I'm asking you to do it both ways, and I really do want you to take the time to do it both ways. We won't always do that, but just for verification, it's always good to check your work also another way, so you'll be checking your work in the process. So you can go ahead and do these problems in your My Math Lab assignment, or you can watch my next video is going to be on the quotient rule, because we have the same issue when we're dividing, that we can't just do the derivative of the first term or the numerator function and the derivative of the denominator function and then just rewrite our fraction as the derivative of both. So we are going to have to do a rule for that as well. Oh, I almost forgot to mention that I have a video in a song in Schoology. So if you go to Schoology, you will find a link for the product rule song. I know you're all dying to hear it. That's what I would do right now if I were you. Enjoy.